So you might have noticed that a lot of number theory problems can be solved solely off of guessing and checking. And that's what we're going to do in this problem right here. So the number 13, this is an older math counts problem, so all the credit of the problem goes to math counts. The number 13 is prime. If you reverse the digits, you also obtain a prime number, 31. What is the larger of the pair of primes that satisfy this condition, also a sum of 110? So basically, if you take 13, which is prime, and you reverse the digits, you get 31, which is also prime. So we're looking for the larger of the pair of primes that satisfy this condition, and, like in this case, the sum of 13 and 31 is just 44, because 3 plus 1 is 4, and that's 4. So in this case, they have a sum of 44. We need the larger, in this case, the larger of the pair of primes is 31. So we're asking for the larger of the pair of primes that satisfies this condition. So if we flip a number around, we have the prime, we're supposed to get another prime, and it should satisfy the condition, and both numbers should have a sum of 110. So in this problem, I'm going to work my way up of primes and start from 13. We know 13 and 31 don't work out. So we go to the next prime, 17. Now, if we reverse the digits of 17, we get 71. Now, both of these are prime, so it satisfies the condition, right? But does it have a sum of 110? We'll find out right now. 7 plus 1, what's 7 plus 1? 8. 7 plus 1 is 8. 88 is not 110. So it doesn't. So we have to move on to the next prime. But now what we're going to do is we're going to go to 71. 71 is a prime, right? We know 71 is a prime. I'm going to go to the next slide here. 71 is a prime. If we reverse the digit of 71, we get another prime, 17. Well, let's go to the next prime in the 70s. So if 72 is composite, 73 is a prime. And let's reverse the digits of 73. We get 37. Now this looks pretty promising because I can already see we have a 0 over here. And 7 plus 3 is 10, plus 1 is 11, and we have a 0. So let's just check and make sure these are prime. This is prime for sure, and 73 is also prime. So they're both prime. I'm going to label it since we know it's prime. Let's add it up and see if it's 110. 7 plus 3 is 10. We have a 1 over here. 7 plus 3 is 10. 10 plus 1 is 11. And their sum is 110. So we have we have a case here that we have 37 and 73. Both are primes. When their digits are reversed, they remain prime. So, and their sum is 110. We're looking for the larger of the pair of primes. We have a pair of primes here, 37 and 73. The larger one is obviously 73 since, So, the answer is 73. So, by understanding how you can get to the answer without just following all the steps I did, you should be testing back and forth. Like, I tested 17 and it didn't work out. And I know that 71 is prime since 17 and the pair of primes, 17 and 71, satisfy the condition where the condition is if you reverse the digits of a prime, the new number is also a prime. So that's basically what we did over there. And obviously, since it didn't work, we could have gone to 19, and that wouldn't work. But if we went to 19, we would have overshot it, so we would go back to our 17, we would go to the next prime after 71, and then we would get 37 and 73. So a good strategy in these types of problems is there's no, you don't have a faster solution or whatever. Guessing works just fine if you have a good plan. Like if you're just going to test every single prime all the way up to 90 or something, you're not going to get the answer. But if you strategically plan out your guessing and checking your guesses, you might as well end up to a solution. So hopefully this video is helpful, and yeah.